Hello, my name is Adaida Lid Cortez, and in this video, we will take a look at the decisions that were taken in the engineering process of a purchase tracking software. Everything from a C++ lens, which is a programming language of my choosing, and within an object-oriented systems design paradigm. So, before we begin, we must take a look at the requirements of the assignment so we may understand the user stories. In other words, what we aim to achieve with our program. So let's go with our document over here, and we have a section for the desired interface, option menu that displays the following functions. So first one, we are seeking to be able to search for an item within the input name. So essentially, I want to be able to have my interface, and if I want to look for a certain item, I should be able to look it up by name. That is essentially the first function. Number two, print all item purchase frequencies. That means that we will have a list with all of the items that have been purchased and a counter of how many items have been purchased. For example, 2 apples, 4 bananas, maybe 6 pineapples. So print all item purchase frequencies would be able to see how many times each of these items has been purchased. Number three, print item histogram. So essentially a graph that would show us the frequency of purchase for each of the items. Again, apples, bananas, pineapples. And finally, a function that allows us to exit the program to end the execution. For the implementation, I have chosen an object-oriented paradigm, which has the following characteristic: creating abstractions, in other words, blueprints, for objects to represent their attributes or traits and methods or behavior. So this sounds a little bit confusing, but it truly isn't. So, for example, let's say I want to create an abstraction for something as simple as, let's say, my water bottle. This is my favorite water bottle because it's huge, so let's go with this one. So, create an abstraction, a blueprint. Basically, I will create a mold that will explain what a water bottle is without actually having to show you mine. So first, we will start by representing the attributes of my blueprint. So in this case, my water bottle, well, let's say that some of the attributes or characteristics it may possess may be, for example, the color. In this case, my water bottle is a pretty peculiar color. It's a pretty bright pink. So that could be one of the characteristics. Another one, well, let's say maybe the liters, the amount of liters that it is able to hold within it. And finally, let's say temperature. Let's see, do I like my water bottle to be chilly? Do I like it warm or just room temperature? So these are maybe some attributes that you could have for the water bottle. Now, what methods, or in other words, behaviors, could this water bottle have associated with it? Well, maybe it could be pouring. I could pour my water bottle, or I could fill it up. Those are two functions or methods that I could attribute to my water bottle class. So this is something similar to what was done in this project, except we are talking about purchases from a grocery store. Now, in terms of data structures, I would recommend to go with an ordered map simply because we'll be doing a lot of searching. We are going to be searching for specific values within our collection, for example, apples, the pineapple, the oranges. So in this case, because we will be doing a lot of searching for the values and in not a very specific order per se, it would be most efficient to use an order map instead of, let's say, a vector. And in case we use the vector, what we would have to do is have to go value per value, just one by one, in order to find the value we were searching for, which would take quite a bit of time, especially if we're working with larger data sets, just larger shopping lists. In the case of order maps, the big O notation for the complexity would be big O of log n, which is much more efficient than just going one by one. So that is the preferred data structure we will go with for this project. Now, before we actually analyze the code, there is something worth mentioning within the structure and engineering decisions themselves. And if you take a look at the file, you can tell that there are a lot of documents here. It's not just one. So let's just understand why this decision was made. So first of all, the use of headers makes it easier for the compiler to understand what the project wants to achieve and the overall structure of it. So we've included headers. The rule is one header per class. So I have my grocery exception header in this case. This is just to inherit for exceptions so that we can create our own class that inherits from the general library exceptions class. So we can create personalized exceptions in case something happens to go wrong within the runtime of our code. The second header we have is grocery tracker, which has all of the main methods that we will be delving into a little bit that make all of the calculations possible. And finally, we have the product header. This one is the blueprint for the products that the clients have purchased in the store. So one header per class. Now, usually we also have one CPP C++ file per header. So you can see the grocery tracker over here. We have grocery tracker in C++. And for the product, we have also, where is it? I cannot see it. Oh, just above it, product C++. Now, for the grocery exception header, there is an exception, and that is because the implementation of this code is very brief, so it was not necessary to have a separate CPP file with all of the logic. So let's move on. And now we have the README file basically so we can understand a little bit more about the code and the program itself without having to open the source code. Here we can take a look at the UML model I designed. So basically we have the class grocery exception with its unique method. Then we have the product class with its two corresponding attributes, in this case, the name of the product and purchase count of how many times that item has been purchased. And here are the associated methods. So just first, the constructor, so that we can create an object of this class. Get name, because of encapsulation, we need a public method in order for other classes, like these two, particularly the purchase tracker in this case, to be able to access the attributes that we have hidden within a product, just for safer code. So we have the get name function, get count function for the second attribute, and finally increment count. Well, essentially, we have included this function within the product class instead of putting it in the purchase tracker, simply because product should be able to handle its own increases and decreases so that other classes don't have such direct access to its attributes. And finally, let me just shift this a little bit because I cannot quite see it. Okay, so finally for the purchase tracker class, we have the map that we will use as a collection for our data and the methods associated with it, process file. Well, this is because due to the requirements of the assignment, we should be able to take a file and that file will have a list of purchased items. So from that file, we will extract the information necessary in order to know which products were purchased and how many of each. So that is why we have the process file method. Then save backup as well. Part of the requirements of the activity is for our program to have the option to save a backup and create an external file, a new output, where we basically save all of the analysis that we have done. So like the items purchased and the number of purchases per item. Another other methods will be search for, which is the one we discussed, so that we are able to look up if a certain item has been shopped for and how many times. And finally, the print histogram method that will show us a display of all of the items and their purchase history or their purchases. Now, taking a look at the actual code, let's start with our sales tax. So here we have the text of the purchases with which we executed our program and testing. So here we just have a series of regular grocery items. We have spinach, radishes, broccoli, peas, cranberries, and then broccoli again, zucchini, cranberries, onions, cranberries again, zucchini again. So this is the file that we will use for our example. Let's take a look at our headers. When you compare them to the other files that we will see in a bit, you can tell headers are significantly briefer, and that is by nature. Their purpose is simply to explain to the compiler, hey, what's going on? Like, what are we working on? What classes, what attributes, what methods? let me see what we're working with before actually showing it all of the implementation and logic behind it. So we have grocery exception header, the grocery tracking header with its own constructor and other methods, and the product header as well over here. Very brief. Now, let's take a look at a grocery tracker file here. So basically, because this is one of the files that has most of the groundwork and the heavy lifting, we are going to use first the constructor for the implementation. So here our constructor will actually be empty because all of the logic will be handled by the map, because it's a pretty simple program. We don't need to scale it yet, so we're just working with a single map. Now, here are the implementations for the file input. In this case, what this part of the code does is just basically scan the file. In this case, it says file within the data. If you can see over here, we have our folder named data, and within it, we can find the file that we're referring to. So it will extract the contents from this file, and we have a little bit of safeguarding going on. So if the file is not able to open, we will throw an exception. That is why we have our unique exception class over here, grocery exception. And we'll simply print the message, could not open file, and the file name. After that, we have okay, yes, here we have a loop, and it says read file word by word. This is what this part of code usually means. So essentially, what this part of the code is telling us is while in file, item name. So while we're reading the file, we're gonna go word by word, and each word is an item name. So if it exists in the map, increment. Otherwise, insert. What does that mean? Well, if the item we are looking for, and we're looking for it using an optimized function here called find. So if the item we are looking for is already part of the map, we're going to increment the count. Remember, each item, each product has its name and the product purchase count. So if this item is already on our map, it means that we have already read this name, this key. Then let's increment the purchase count, because if I'm reading it again, it means that, well, someone already purchased it. So let's add 1 to that. In the case that it does not exist in our map, it means that this is a new product that we hadn't registered as purchased before. Therefore, we will insert it, and we will set its purchase count to 1, because this is the first time that we have seen it being purchased in our history. Now here, all of this logic is essentially same sort of syntax except for the output, and what this does is create a new file where we create a backup when the main method calls for it, when the main part of the program calls for it. Here in the function search for product, it's pretty straightforward. So we basically have a conditional here, and it tells us that we should call for an optimized search function here with using find again. And we're looking for the specific value, and in this case, the key that the user will input. So apples, bananas, pineapples, you know the drill. So here, if we are able to find it, we will return second. So in this case, because with maps we work in pairs, so we have the key and then the value, it will return the value. So how many times that item was purchased. And in the case that the item that we're looking for is not within the map, it does not exist in the map, it will return nothing basically, because it was not found. And for the print purchase count, excuse me. So here we're just iterating over the collection, and we are using the function get count in order to obtain the count for that specific product that we are discussing in this certain iteration, and then we will go on to the next item. So basically, we will, let me delete the drawings here, we will print an asterisk for every value, let's say every time the item was purchased. Therefore, our results would be at a collection of asterisks representing the amount of times that item has been purchased. So now that we have looked at our tracker, let's peek a little bit just into our main so that we can see the flow of the program. We used display menu. So here are going to be the options that our user will be able to see on their screen. These are being printed on the screen through Cloud. And then based on the user's decision, so here we have the options, and these are received through the input here with computer input. Here are some of the options. So for example, in the case the user chooses to print the histogram, well then we will print histogram of purchases and call to the function that has this behavior. Or if the user decides to save a backup of the information that it has already processed, well then we're going to call to the function save backup. So when you can see, our main is actually pretty clean. We're just calling to the other functions that we have already described in grocery tracker. So here we're just essentially telling the program in which order we want to use these functions, but the actual implementation, the logic, and all of it is hidden away in the abstraction of our other files. So now let's look at an example of execution of this code. So here I have my command prompt, and now we have a lot of files, but the only executionable file is stock_sync, which is the silly title that I decided to give to this project. So I'm already in the correct part of my directory. So let's go with stock_sync, and I cannot see anything, and execute it. So let's go. Grocery tracker menu. So these are the options that we discussed. First, search for an item. Remember, we'll search for it based on its name. 2, print the histogram. 3, save backup. 4, exit. So let's start with search for an item. Let's see here. Welcome to the product search. Oh, so welcoming. So name of product, name of the product that I'm looking for. So let's see. I want to know if my person that went on this shopping journey bought any apples. So let's see, found apples purchased 4 times. So the apples were purchased 4 times according to the list of purchases that we saw earlier. Now we have our interface and menu again, because this is on a do loop that will not cease until we choose to quit and end the execution of the program. So let's go with print histogram. Let's see what that looks like. All right, so here we have a list of all of the grocery shopping items that we saw the products before, and each asterisk represents each time that product was purchased. Therefore, one of our most purchased products in this list were, I believe, zucchini, maybe peas, cranberries. So those are the most purchased items. It's a pretty interesting pretty interesting grocery list. And finally, we have a save backup. So essentially, well, this won't really give us anything on screen, because what that piece of code does is create this file where we have a backup of all the information that we have processed. So here, if we are able to compare it with the, let's see, the histogram we saw earlier, we should be able to see that apples 4 corresponds with 4 asterisks, beets 3, 3 asterisks, celery 6, let's see, whereas the celery here, 1, 2, 3, 4, 5, and 6 corresponding asterisks. So yeah, this is a simple example of the execution of the code. Thank you so much for watching this video, for listening to me ramble about all the little nitpicky decisions that went into the making of this program, and I will see you next time. Goodbye!